Okay, we're going to go ahead and get started. I want to thank everybody for joining us. My name is Sherwood Zern. I'm a product manager in the OCI Developer Cloud Adoption Team. And again, thank you for taking time out from your day to join us. And also thanks to Marcy Samuelson for putting this all together. I just want you to know that you'll definitely be rewarded with an extremely informative presentation from the vFunction staff. We have Amir Rapson, who is the CTO and co-founder. And we also have Bob Quillen, who is the Chief Ecosystem Officer. And in addition to the vFunction staff, we also have Monica Riccelli from the Oracle's WLS product management team. Monica was happy to be here to answer any of your questions regarding your running of WebLogic server on top of Kubernetes. And then in addition to myself from the cloud adoption team, we also have Robert Ronan. And we are here to answer any questions you may have during this presentation. If you do have any questions during the workshop, put your questions in the Q&A section. Because we do have people here that will be able to answer those questions. And then at the end of the vFunction presentation, we will then also have a live Q&A session after the presentation. And also keep in mind that this is being recorded, and the slides and the presentation will be made shortly after the webcast. So again, thank you for joining today. And before I do turn it over to Bob and Amir, just want to take a couple minutes just to talk about Oracle's container engine for Kubernetes. This here is Oracle's safe harbor statement. Anybody that's attended an Oracle presentation is aware of this, and it's just, saying that, obviously before you make any decisions or whatever that about buying things, Oracle products, obviously do your due diligence, if you will. And also, if we talk about anything that may be in the future, don't make any decisions based upon what potentially could be in the future, because things change over a period of time. But for the most part, I don't think there's anything that we're going to be talking about in future enhancements of any of the Oracle products, but basically where they are today. So let's first talk about Oracle's Kubernetes as a service, their container engine for Kubernetes. So OKE, as it's commonly referred to as, it's fully manageable, scalable, and highly available service that you can use to deploy your containerized applications to the cloud. It's obviously based upon the upstream version supported by Cloud Native Computing Foundation, CNCF. Therefore, this means you have no vendor lock-in, and you don't have to re-architect your application when moving from an on-premise Kubernetes. So if you look at this slide and see what it actually provides for you, you can see if you were to do the management of your Kubernetes yourself, how much more work is required by the customer, as opposed to if you're using Oracle's OKE managed service. So you can look at it, you have faster time to deploy, you have better reliability, lower risk, and accelerate innovation. And because of this, that means that you as a customer can spend your resources on building your application and innovation versus maintaining that infrastructure. So Oracle's cloud native services are built on top of what we refer to as Oracle Cloud Infrastructure, or OCI. We have several services, cloud native services, and we categorize them in application development operations or observability and messaging. We have several of the services. We have fully compatible Kafka. We have logging compatible with Fluentd, native monitoring, events, API gateway, and then functions, and then also several other services that will assist you with your most demanding workloads. And since OCI and OKE are based upon open standards, you're more than welcome to bring your own open source software that you're familiar with to use along with Oracle Cloud Native Services. So this slide just contains a few examples of what Oracle has been doing with respect to open standard services and supporting the Linux community in general. Oracle is a platinum member of Cloud Native Computing Foundation and a member of the Open Container Initiative Linux Foundation Project. Oracle is the only major cloud provider to deliver and support a unified cloud native solution across managed cloud services and on-premises software. So to put that in a nutshell, you can take it as an example. You have an application running on WebLogic on-premise, and then you want to shift that to OCI, and you want to run that in the cloud. Well, with the WLS operator, and obviously, if you have any questions around this, Monica Riccelli is the go-to person. She can answer any of your questions if you have on this. And then you can lift and shift because we can containerize WebLogic server without having to re-architect or rewriting your code. This makes the migration of your WebLogic server application very easy. So what does OCI provide? So you can have bare metal, you have virtual machines, containerized compute, GPUs for performance intensive workloads such as AI, ML, and a variety of cloud storage options like block, object, file, and archive. In addition to that, OCI offers a fantastic array of services for developers to build modern applications, and OKE uses OCI as the main platform for its services. Oracle does not restrict you to one or two programming languages. You have the choice to use what you are familiar with and what your organization uses, whether it be Java, JavaScript, Node, Go, Python, Ruby. You choose, and you can run it on top of OCI. So let's take a look. Let's go back to OKE and OCIR. OKE runs highly available Kubernetes clusters. It's developer friendly, enterprise ready managed service, keeps pace and compatibility with the CNCF subsystem ecosystem. OCIR, which is the Oracle Cloud Infrastructure Registry, is a highly available container registry. This service enables you to easily store and share the container images. It allows your users, just like any other image repository, allows you to push and pull images with the Docker CLI. So let's talk a little bit about what everybody eventually gets down to is the age-old question. Let's talk about pricing. Okay, what is all this? What is all these wonderful things are going to cost me? So let's take a quick look. Here we have on OKE, OCIR, and I'm going to just briefly talk about pricing at a very high level. So if you look at the costing model, the gray area on the left are the areas that Oracle manages. That's all what Oracle manages. And then on the right is the components that the customer needs to manage. So if you look at this, that means on the OKE, OCR, so what you have is etcd and the master nodes are also is what's being managed. You have upgrades are supported in the container engine dashboard. It's very easy to upgrade the master nodes. And the nice thing is you decide when you need to upgrade. The customer, all you need to do is manage the worker nodes and your application that it's running. So let's look at this. So OCIR, if you look at the registry, that's completely free to you. Also, the managed pieces, the master node, etcd, and they are high availability. Those are also free to you. You do not have to pay for those things. The only thing that you have to pay for are only those resources that you're using. So, that would include things such as your VMs, your storage, load balancer, and the images that are stored. So you are having to only, if you look at the whole picture, is only having to look at paying for 1/3 of the whole picture there. And it's really just based upon what you use. So I guess if you wanted to shut down your Kubernetes cluster at night, it's not being used, you don't have to pay. So then let's look at, so another aspect is the service broker, and that is a component that makes it very easy for you to connect to some of your services, your microservices. You want to connect to some of the cloud native offerings, and that would be things such as our popular ATP database, the autonomous transaction processing, ADW, the streaming service, and the block storage, the storage cloud native. Now, there are things when, if you want to talk about persistence, there obviously you have the two types of applications. You have stateless and you have stateful. If any of those have done any of the work, obviously the stateful is usually much more complex, but OKE provides services and capabilities for both stateless and stateful apps. And then just let me wrap up with this last one here is, some of the highlights of OKE, what has been recently put into place. One of those is you're able to run on Kubernetes version 1.19.7, the Cloud Shell integration with OKE. And then also what I think is wonderful features are the autoscalers, horizontal pod, vertical pod, and also the cluster autoscaler. And so with that, I will turn the time over to Bob, and he will take you into the vFunction.
Thank you, Sherwood, very much. We're definitely excited to be here and to demo how vFunction can really help you modernize the job applications that you have into microservices and accelerate this cloud native journey that Sherwood just walked you through in terms of what's going on in Oracle Cloud and kind of across the whole cloud native ecosystem. I'm Bob Quillen, and I'm responsible for the ecosystem and developer advocacy at vFunction. I'm joined today by Amir Rapson. Amir is the co-founder, CTO, and he'll actually be walking you through a demo of the MedRec application, which is a classic sample WebLogic application. I hope some of you are familiar with. It'll demonstrate a lot of the microservice decomposition capabilities that we have and that we're providing to customers today. There's more information available on our site. There's a MedRec tutorial page on vfunction.com. Feel free to check that out later. Reach out to us. Those are our Twitter handles or info@vfunction.com. We'll get you there too. So let's talk a little bit about the scope of the problem and really the specifics of what we're focusing on today. We're really focused on those applications that have not been moved to the cloud or cloud native yet. And that's really the vast majority of enterprise applications in the entire enterprise application estate. And in that group, there's the majority of those are Java applications. So this is really a major problem. There's millions, if not billions, of Java applications out there that need to be moved to the cloud native environment. Now, to date, cloud migration is focused on lift and shift as really the de facto approach to move workloads up to the cloud. People have been rehosting and trying to rehost applications by putting them in a VM up in the cloud or replatforming, maybe plopping the entire app into a container. But really that has disappointed both the enterprise and even cloud providers because you're not really able to leverage the full value of the cloud, particularly engineering velocity, elasticity, business agility, all those great value propositions that the cloud can provide. So, and to do that, you really need to start focusing on refactoring. There's a lot of refocus now around refactoring of how to move applications and move them into a microservice architecture, but that's been really, really difficult. It's a very challenging and very manual process today. very consulting intensive, usually requiring months and months of time in a locked conference room, lots of money, and sometimes resulting in very disappointing results. One of the key issues is that there's really been no innovative technology or automation that's been applied to this particular problem. So, and that's really where vFunction comes in. And our vision is to expand the footprint of those applications that can be refactored and really provide another option to move to microservices much more quickly and take advantage of the cloud in a much more efficient way. So what does vFunction do? We're a cloud-native modernization platform, and this is for developers and architects. And you'll see that as we go through the demo, we automatically transform Java monoliths into microservices, and we're purpose-built for that particular use case. The technology is very innovative. It combines both dynamic and static analysis, data science, graph theory, lots of automation to build out what is used by customers today to not only modernize one application, but typically they have tens or hundreds of applications out there in their backlog of Java apps that need to be modernized. And they're starting to build out this scalable, repeatable factory model to really reduce that backlog of legacy applications and get them to the cloud and a cloud-native architecture. vFunction's being applied across the cloud migration process today. Early on in the migration phase, where people are looking to assess the complexity of their application, build a modernization plan. vFunction is being used to do data-driven analysis, so we can analyze the complexity of the applications, determine which ones are receptive to a refactoring model, maybe which ones should be rewritten, maybe are retired. Once you have a plan in place, really that's where the vFunction platform takes over for refactoring. You'll see that today in the demo. And then once you have one or two applications completed, many of our users are starting to now expand that to a modernization factory model to reduce that backlog of applications and build a pipeline to move those applications forward into the cloud native environment. The vFunction platform itself, at a high level, takes place over 3 phases. And that first phase, the learning and assessment phase, really has a both dynamic and static component. This is where we learn the application. The dynamic analysis uses a native JVM agent, and usually it's deployed in QA or staging. It can be also deployed in production too. And that actually observes the business flows in the application, much like an APM, or application performance monitoring agent, sampling threads, analyzing call tree, but a very detailed business flow and business logic level, memory and more information. We then apply static analysis to those results. Where we're going to look at compile time dependencies, spot dead code, and all that is synthesized into a recommended microservice architecture, an initial architecture in the middle phase here, which is a very interactive environment where the user can look at this topology and then begin to refine it. They can split services, they can combine and merge services together, they can actually build new APIs and really begin to build sharper boundaries between the microservices so you have something you're very comfortable with in a very interactive way that's enabled by vFunction visibility and automation. And the final phase is then you extract those set of services or microservices out. This is the first time you actually need access to the source code. The static and dynamic analysis takes place on the JVM and the bytecode. Here we're actually then just taking out the minimal context of the source code that's required. We build new projects and new microservices that then could be deployed on the far right to any cloud native environment. You'll see today us using OKE, as Sherwood walked you through, on top of OCI, and it's a pretty cool demo. So to that, I'm going to now stop sharing and hand it over to Amir, who will take over and do a demo of MedRec, and let him take it over from there. Thanks.
So this is what I call a 15-minute drill. I'm going to show you in the next 15 minutes how the vFunction platform works. So what's the flow through the platform? We're going to analyze MedRec together. The MedRec is the sample application that comes with WebLogic. We're going to analyze it together. Then we're going to extract the service. So really take the source code from the MedRec sample application and extract the service from it, and then compile it. And eventually we'll also containerize it and run it on OKE. And I'll try to do mostly, everything will be mostly live. And that's it. So let's start. We don't have a lot of time, so let's just start the flow. So this is the flow of the vFunction platform. As Bob said just moments ago, we combine dynamic analysis and static analysis to analyze the running application. So what it means is that we have something running on the JVM, and that collects all the information about what's actually running on the JVM. So we collect these call stacks and we understand which methods are running, which classes are running, and we also know how to tag certain objects that may pose constraints to extracting services from a monolith. So anything that might hold state, anything that's being accessed. It could be like database connections. It could be access to database tables, but it could also be like singleton string beans. With that, we also collect all the static analysis information. So we don't only look at what's actually running, but also what are the dependencies, the compile time dependencies, the injected dependencies if you're using Spring or similar technology, the property files, configuration files, everything. And this information together, looking at them together is actually very powerful because it allows you to not only understand what's running in a very succinct way, it also tells you what you need in order to compile that service and extract it. And just a small piece that if you think about it, if I take the dynamic analysis and result and subtract it from the static analysis, means what's actually running subtracted from what's a dependency, I can find a lot of dead code in my application and a lot of dependencies that simply don't need to be there. Now, all of this information is sent to a server, to the vFunction server, which is on-premise. It runs alongside your application, where you have a completely interactive platform in order to view and make decisions regarding the analysis and the extraction of the services or on the decomposition of the system. So what we do here is we first of all optimize for exclusivity. So we get all of this information from the static analysis and the dynamic analysis, and here we try to solve a mathematical equation which optimizes the exclusivity of classes and constraints. So think about it that if you want to now define services in a running application, you want for each of these services to have a high exclusivity of classes, meaning a high percentage of classes that will only exist in that specific service. Because otherwise it will mean that you have interdependent code and code that's going to be shared between different services, and you really want to avoid that when you're defining new microservices. The exclusivity is also, as I said, it's not only optimizing for class exclusivity, we also want to reduce constraints. So let's say there's a certain object with some state in it, and it's very hard to kind of split that state between two different services. So we want to make sure that services have their own state. This is completely interactive. So the problem that we solve is a mathematical problem, but it only solves it based on how the code is written. And architects have their own ideas, and coming up with the right architecture is something that a person should do. So this refinement of the boundaries of the services is something that we'll go over in the next couple of minutes, and it really gives you all of the flexibility to find the resulting services exactly the way you want. Once you're happy with the services, or once the architecture is happy with the decomposition of the system, you can download a service specification file onto his development machine, where he can run our tool called code copy. I'll show this to you also, to actually extract the service from the code repository, compile that service, and then finally deploy it as services. And this, of course, can be an iterative process. You can extract the service, go back and analyze some more, etc. So now let's jump to the UI. This is the analysis screen of the vFunction application. Every circle here is a service. The size indicates the size of the service in terms of number of classes, and the color indicates the exclusivity, the level of exclusivity. So high exclusivity is green, medium exclusivity is blue, and lower exclusivity is red. So this is like a high percentage of exclusive classes. This is a low percentage of exclusive classes. And we get some metrics, and we get the names of these services that are based on the methods that invoke the service. So it's really, you can understand the system. Now let's dive in a little bit. If you know the MedRec application, there's a module called patient chat. Let's start with that. So this is this service right here, and the patient chat. We can see that it has one entry point. We can explore it. So there's the on message on the WebSocket starts this flow. We can also see that there are 3 classes that were found in the dynamic analysis related to the service. We can view those. It says that it has 33% exclusivity. So 1 is exclusive and 2 are not exclusive. Let's say I want this chat service to be exclusive to the service. So I can click right here, click on the details, and see that it's told that it's needed not only for the patient chat WebSocket service, but also for the physician chat WebSocket. That actually makes sense. And if I click here on the physician chat, I see that it's, I can see exactly where it's called from. So this is the call tree. I can go up the call tree and see and get all the information I need. Now, let's say that I want these services, this physician chat WebSocket, to be to merge that with the patient chat and make it into a single chat service. So I can decide, for instance, to click on the merge here to merge between the services, or I can also show you. I have these 2 services. I can simply drag one on top of the other, and the system will just merge those 2 services. Now, with every change I perform, the system calculates all the metrics and exposes to you all the meaningful information, what it means to decompose the system in that specific way. For instance, here we see that the exclusivity went up to 100%, both from a dynamic analysis and a static analysis. There are no resources involved, so no constraints. Let's name this the doctor-patient chat. I'm renaming it because we also have a tutorial for MedRec on how to analyze and how to decompose MedRec. So we have on our portal, and that's very detailed. That's what we name it there. Once we're happy with the service, we can just mark it as a candidate for extraction. It will appear here on the list. Now let's look at another service, maybe a slightly more complex one, searching patient controller. So it has 3 entry points. We can see those here. Let's go back to services, 5 dynamic classes, 31 classes found through static analysis. Let's look at that. 100% exclusivity. There are 31 classes here, but there are also 28 classes that are infra. Infra classes are classes that the system found to be common to many of the services, and it suggests to put them in a common library. So if I just look at one of these classes, you see the found patient. So this is from the COM Oracle MedRec Facade model package. So this package is the model package. I can make a decision that, okay, actually all of this model package, I want it as an infra library, in the common library. So I can just click mark packages infra. I don't know to put it there. But I also see some classes, and by the way, I can also look at the details and see where it's used. So I see it's used in multiple services, but I see some classes here that I don't want them to be in the common library. So as an architect, I can make a decision to say, okay, this base physician page controller class, actually don't want it as an infra. I want to mark it as non-infra. And then it will move from the infra classes to the non-exclusive classes. I'll do this also with the patient service, the physician service, and the record service, because I don't want these service classes to be in my common library. Now, just putting those in the non-exclusive classes means that these are classes that I'll have to look into later, and these may be classes that I will need to refactor. Let's look at one of them. The analysis completed running, so I can see that all of them are here. Actually added quite a few others, because for every decision, you know, if you you say that a certain class is not going to be in the library, so all of this dependents shouldn't be in the library either. Let's look at the space physician page controller. I'll skip here to a slide. I'll show you the source code of that class. So the base physician page controller extends the page controller support, and it injects the physician service, the patient service, and the record service into everywhere that it's used from. Now, in our case, in this searching patient controller, we only need patient. We have no need for the physician service or the record service. So what I can do is I can see the dependency graph, and I can say, okay, this base physician page controller, I don't want it to have a dependency on the record service. So I can mark the record service as dead code. Now, this dead code is not traditional dead code. It's not the dead code that's completely unreachable. It's just something that's not reachable in this specific flow of the code. So it's a very powerful aspect to just, so you can really completely refactor classes or automatically refactor classes based on this interactive platform. So I will actually do the same. So you see here, there's a little asterisk here. It means that it's automatically refactored that class now. Let's look at it again, because I also want to not only, so this record service is now marked as dead class. I also want this physician service to be marked as a dead code. So I'll mark that as dead code as well. Let the analysis complete running. And once I'm happy with it, I'll just mark it as another candidate for extraction. Now, I don't always have to get to this 100% exclusivity, because in real life, you don't get to this 100%. But it just means that we'll have to do some refactoring later, which is totally expected. So I'll click here. I see that as the candidate for extraction actually have three: the doctor-patient chat, the patient search, and the common library that's going to be required for the patient search. Let's see how we extract these services. So now I was in the analysis tab. I see that the service creation is available now that I have marked some candidates for extraction. I click on create services, and I click here on download. It will download three files, three JSONs. Each of these JSON is actually the service specification file that it tells me which classes are required. And this JSON is the input to our code copy tool that I'm going to show you right now. So here we are moving to a different window. This is on my local machine just now. I already downloaded the specs, so you can see the spec files. I downloaded quite like a couple of more specs. All of these are available as part of our MedRec tutorial kit. So you can start from any place in the tutorial that you'd like. But and I hope that you did see that with this interactive platform, you can make informed decisions about how to modernize your Java monolithic application. So I have these specs and I have these services. I'm now going to start extracting these services. So let me copy here. What I did is called the code copy. I gave it as a spec file, the doctor-patient chat JSON that I downloaded. I told them to create this service under the services doctor-patient chat based on the source, which is the source of the MedRec sources that are distributed with a WebLogic server. I can then, I'll just make a slight modification to this service here to actually create replace the POM file that we created for the doctor-patient chat. We do create like a rudimentary POM, but here in this specific case, I had to replace the parent POM. This is something that you'll see in detail in the tutorial. And if I go here and I just click Maven clean install, it'll just compile the service for me. And that's it. We have an extracted service. Let's do the same for the common library. I'll replace the POM here as well. Go into the common library and even clean and install. Okay, and then I can continue to do that for the rest of the services. I won't do that here, but the result is going to be a couple of WAR files. And I want to take all of them and extract them as services. Let's go now to OCI. So here we have a machine running an OCI. I already copied all the services here, and I'll show you on a slide what I'm going to do now. So what we're going to do is containerize and run these services on OKE. So we started by installing the WebLogic server Kubernetes operator on OKE. So now it will listen to the domain kind. And then we're going to create a container using the WebLogic image tool and upload it to a Docker registry. We're going to use the model in image method. The model in image method means that in the container we have in it the WebLogic deploy tooling, so WDT, the model file, a target WebLogic version, so which WebLogic server to create, and the service WAR file itself that's going to be deployed. So what it'll do, this WebLogic image tool, it will take the model file, it will know how to create its own container, it will bring up a WebLogic cluster, and run this service WAR on it. Then after we're done with that, we're going to install a domain manifest with the custom resource, with a domain custom resource, and point it to the container image and a config map containing the details on the data source. And then the operator will extract the WebLogic deploy tooling and create the WebLogic cluster, which is really the operand of this operator. So all of this sounds like a lot, but it's actually very comfortable to use. And I'll simply run a single script that we have available as part of our package that does everything for you. So I'll run this bash install. You see it now is building the image. The container, the operators are already installed. We see that all the deploy properties, all of the information is there, and it'll slowly deploy the services. Here we see the doctor patient chat zip, the WAR file, the model properties, the WebLogic deploy, and that's created. Now, after a few minutes, so that's going to take a little bit longer than what I can do in this demo, but I'll just duplicate this tab here and show you. So I just created the MedRec namespace, but I already prepared the MedRec, another namespace called MedRec demo just a few moments ago. So let's see those pods, MedRec demo. And we see that everything is running. So after like 10 minutes or so, what you'll see is those 3 clusters running on OKE. Here, it's the doctor-patient chat service, the patient search service, and the record management service, which is another one that I took, if you remember, from what I showed you under services. So we had the doctor-patient chat, the patient search, and the records management, and all of that is now deployed on OKE, and all within 18 minutes. That's it. Back to you, Julie.
All right. Thanks, Amir. Yeah, so there's some resources that are available, and I want to share those with you real quick here on our vFunction site, MedRec tutorial and vfunction.com. There's access to the videos. There's actually portal access you can request, like case studies, ROI. And to learn more about the tooling, definitely jump in and look at what Monica and her team has provided. That's up on GitHub and in the Oracle documentation. There's free trial for Oracle Cloud. If you want to run the whole thing up there, we highly recommend that. And please reach out with any questions to myself or Amir, info at vFunction, and we're actually ready to answer questions. So.
Yeah. So again, thank you everyone for attending. And Now, if you would like to ask any questions live, feel free to do so. It's a great opportunity to talk to Amir and Bob or Monica about moving and doing a lift and shift of your applications from, a WebLogic container into Kubernetes and Docker containers. So please feel free to ask us any question that you have. So go ahead.
So this is Robert. I've got one question that came across that I wanted to ask on behalf of one of the attendees. It's sort of a two-part question, so I'll ask it in two sections here. So, where does vFunction run?
Okay, yeah, I can answer that, and Amir, feel free to jump in too. So vFunction runs on the usually. We see it on the customer's premise, so it's entirely on the customer's premise or on top of their tenancy. So no data leaves that. So everything runs inside the environment or JVM agent. All the analysis runs inside the firewall, so no data leaves that. So it can run on premise or it could run up in the tenancy if they're running, for example, up in the cloud already. So it is a secure and contained environment. So.
Great. Actually, you answered both questions in a single shot. So the second part of that was, does the application data leave or require a firewall? And you definitely answered that. Another question that came across was, does this work with any Java-based app, including Spring, WebSphere, or others?
Yeah, I mean, absolutely. We see a lot of WebLogic. Obviously, WebSphere 2, JBoss. We see a lot of Spring, people moving from Spring to Spring Boot. So there's any kind of JE application. We're seeing that in large numbers. So.
I have a question, Amir, Bob, and that is, when you're analyzing this, is it a requirement that I run, test transactions through my application to analyze the flow, or is it just you take in, I'm assuming, a WAR file or jar file or whatever the case may be, and you're able to do the analysis that way?
Yeah, Amir, you want to take that one?
Yeah. Sorry, I was a little bit distracted by answering a question online here.
Oh, no worries. Yeah, the question was, where does this run, and what kind of analysis is required to do it, and access to the JVM and the bytecode and the et cetera.
Okay. So but the dynamic analysis needs to see what's actually running, and for that you need to pass some flows to the JVM. So on a testing environment, you should put it on a test environment, but you can just take advantage of the existing QA processes. So if you're having like a new release and you have your acceptance tests done on that the pre-production system, then you can definitely analyze on that. Or you can put it on a production environment and just let it stay there for a while and collect all the flows and all of the information. So both of them are possible. The static analysis will be like a safety net. So the system will actually show you what was actually running and then what wasn't running. So if you're missing some functionality and you see it only in the static analysis, but you know that it's there, you can always go back in this iterative process to the dynamic analysis and collect some more data or perform some more tests. So I'll go ahead and answer online a question that we just got that I was starting to type. For a newbie, how hard it is to work with vFunction. So first of all, it's not hard, it's easy. You do need to get used to the concepts a little bit, but these concepts, but we don't just throw this at you. We have a lot of information in our portal, and we will also guide you one of our solution architects will guide you through the initial phases of the analysis and the initial phases of extracting services for the first time. And so you'll understand what decisions you need to make, what are the questions that the system exposes for you, what kind of decisions maybe we can share from our experience in other projects, because we are engaged in many of these modernization projects. And I can promise that by the time we'll leave you to continue the work on yourself, that you will be completely well versed in the vFunction platform and its concepts.
Yeah, there's a question here on how is it actually priced, and so vFunction is priced on a per application basis. Usually one app equals one JVM or at least similar JVMs. We see, as I mentioned, the modernization factory model where many applications are involved, and that's an interesting use case that we're seeing a lot of demand for, where we're selling in packs of 10 or ELAs, but typically on a per application basis, and moving from there. But that's kind of determined during that POC process.
There's a couple more questions up there.
Okay, I'll answer one of them. To analyze an application using vFunction, you don't need to provide access to the code. So vFunction actually doesn't access the code at all. It analyzes a live application running on a live JVM. So it uses standard Java interfaces to understand what's actually running. And it also does static analysis on the bytecode. So on the WAR file or the EAR file or the JAR file, you will need the source, obviously, to extract services from the source. It won't do a complete reverse engineering of your application, but only at that phase where you saw in my demo where we downloaded the service specification spec and then run it on a different machine. So that other machine does need access to the source code, but that's already on your development environment. Another question that we have here, how can I be sure that all of the code was visited or refactored by the tool? So we do have some metrics to tell you that. One thing we can say is that, is that all the runtime, all the CPU time that we saw spent from the dynamic analysis is actually in the decomposed services. So all the services that you define as services you're going to extract, we can see that what percentage of the CPU was actually in those services. So if it's at 100% or over 90%, it's probably all of the monolith there. If it's around 50, 60, then maybe there's some other functionality that we need to look at. If there's some functionality that hasn't run at all in the dynamic analysis, what you'll see in the static analysis is lots of classes that will be marked as purely static, means that they were not found as part of the dynamic analysis. In some cases, the system might interpret that as dead code, and it will expose that to the architect, and we'll ask the architect to validate that that is in fact dead code before making further decisions on that flow. And with that knowledge, an architect can always go back to the code, understand where is that class, and say this is dead code, or say, oh, well, that's actually just a flow we didn't test, and go back to testing.
Hey, Bob.
Yep.
There's a question in chat about. Can you answer that? It's not in Q&A, it's actually in chat. So if you could answer that, how does vFunction handle non-public code dependencies?
Okay.
It says, this is from Scott Woodrum. It says, for example, we might have several many internally developed libraries as a dependency, or does it matter? So the main question is, how does vFunction handle non-public code dependencies?
Okay, so it does handle it. It really works vFunction works in a very fundamental way. So it is framework sensitive. So it does understand certain frameworks to provide a better analysis of the static code that's there, which will also create minimal services. So it, for instance, just as an example, it knows how to minimize string configuration or minimize property files. But other than that, it doesn't care if a certain class is in a jar or is not in a jar. And it will, because it's just another class that's being loaded by the JVM and it's just some methods, it will allow the architect to make a decision. Okay, this jar, I'm going to leave it as a dependency, or this jar is actually code of my own that I want to play with it as part of this decomposition exercise. So the system supports that. All of these decisions are well exposed, and it's very, and all of these questions kind of trickle up through the platform in a very usable and easy way.
Yeah, yeah, there's another question I can answer live too, is about real case examples. And we've got several on our website. We've got Intesa Sanpaolo, who's one of our big customers, largest bank in Italy, top 3 banks in Europe. They actually have deployed us broadly within their environment, built out a modernization factory as a second phase. And there's a case study in there and lots of information about that. We also have some ROI videos from some other customers talking about the ROI in terms of time and value and how much it takes to modernize an application. So there's lots of information on the website related to these various use cases. And then we can answer more, and feel free to reach out for more questions on those things and more answers.
So real quick question here is, you have to deploy the WLS operator because obviously some stuff is still running in WLS. Is there a cost associated with the WLS operator, and how do I deal with WebLogic servers that are containerized and I want replicas of those? How am I priced or on that? And that's probably to Monica.
Yeah, okay, I'll answer that question. No, all the tools that were shown here, the WebLogic operator, as well as the WebLogic image tool and the WebLogic deploy tooling, are all open sourced. They're part of our what we call the WebLogic Kubernetes toolkit. And it's our effort to help our customers move their applications into Kubernetes to make it simpler. So there is no cost in using the operator. And if your customers or if you have WebLogic licenses, these tools, even though they're all open source, they're completely supported in production. So that means that you could call, support, Oracle support, and enter NSR, and things will be addressed. Now, with respect to the cost, the licensing cost when you run your WebLogic servers in pods in Kubernetes, it's hard to describe it here, but the way that it works is, let's say you are running in an OKE cluster in a multi-node configuration, and you restrict your WebLogic pods to run on just one node of your OKE cluster, then you would pay for the CPUs used by that node. So we have a whole documentation on how we license WebLogic running in Kubernetes and specifically in OKE.
Okay, thank you. Again, thank you for attending, and thank you to Amir and Bob and Monica for joining us. We really appreciate it. And we look forward to seeing you and talking to you next month. Thank you, everyone.